Hello, welcome to our IoT Web Day. My name is Philipp Sacha and I'm Specialist Solutions Architect for IoT at Amazon Web Services. And today in this session I will tell you about our AWS IoT offerings as well as about other services that you can use to build fully fledged IoT applications. So what would you do if you knew the state of everything and could reason on top of that data? For example, if you get more insights in your industrial machines, for example, in buildings, in your devices where they are, if you can track devices or things that are shipped, for example, what problems would you solve? So what can we do here for you? Is we do offer a lot of services, especially in the IoT area, which you can use to gather information, data from your devices, and also process the data. So let's start with our offering for IoT in the AWS cloud. So our IoT service, meanwhile, consists of several pillars. One pillar is the AWS IoT Core, and our next pillar is AWS IoT Device Management. Then we have AWS IoT Device Defender. That's currently a service where we are working on, so it's under development. And we have also AWS IoT Analytics. It's also a service where we are working on, and it's currently in preview. I will come to all these stuff for AWS IoT later on and will explain more about the services. Then we have other applications and other services like Amazon S3, which is an object store. We have Amazon Redshift, which is a data warehouse. We have Amazon Machine Learning, Amazon EMR, which is a managed Hadoop cluster. We have Amazon QuickSight, which is a BI tool. What you can use to visualize your data. And we have also AWS Lambda, which is a service that allows you to simply upload code into the cloud and then run this code based on events. Currently we support Python, Node.js, Java, Go, and .NET for AWS Lambda. And it's important to remember AWS Lambda because it's a service which is integrated in a lot of other services at AWS. So please keep AWS Lambda in mind. And then we have also services outside of our cloud. So we are moving, meanwhile, with some of our services out of the cloud into the edge, especially, for example, with AWS Greengrass, which is a service which brings a local message broker and which brings Lambda function to the edge. Greengrass is software, you bring the hardware, and then you can use cloud technologies on your devices. Then we have, meanwhile, a service that is called Amazon FreeRTOS. Amazon FreeRTOS is an operating system for microcontrollers. It's based on FreeRTOS. I will also explain a little bit more during this session here. Then we have also an IoT device SDK that makes it easier to connect to our services like either Greengrass or like AWS IoT. So now let's come to the AWS IoT Core, how it looked like before our last reInvent in November 2017. We had a device gateway where you can connect your devices. We have a device registry, an MQTT message broker, a rules engine, and a device shadow. Of course, we have an API like for most of our services, which you can use to automate things like registering devices, creating policies, and so on. And we had also the connection with a so-called rules engine to send data to other AWS services. So, meanwhile, we have extended the functionality of AWS IoT Core since reInvent 2017. We have still the AWS IoT core, but now we have also services for IoT device management. That means for device onboarding, for batch fleet provisioning, for example. We have real-time fleet indexing and search, which makes it easier to search into the device registry. We provide also a framework for over-the-air updates to update your devices. Then we have the device defender, which is announced, and that you can use to audit your device configurations, monitor the behavior of your devices, and also send alerts to other AWS services like CloudWatch, like SNS, for example. And we have also a new service which is called AWS IoT Analytics, which allows you to analyze your device data. And this is a service which is currently in preview. And today we'll also have a separate session about AWS IoT Analytics. So how does an IoT architecture looks like? First of all, you have here on the left side things. We have sense and act. You have endpoints, sensors, for example, that you can either connect to AWS IoT core directly in the cloud, or we have AWS Greengrass, which is a service, a software which runs on your hardware, which is also connected to the AWS IoT core, and where you can also connect your devices to and use, for example, AWS Greengrass as a gateway. You can also create local communication so that your devices can communicate over AWS Greengrass without the need that the communication must go to the cloud and back. So then we have all the services for device management that I already mentioned, fleet onboarding, management and software updates, and also the device defender and IoT data analytics and intelligence that are other services that you can use to analyze your data. So now let's have a look a little bit deeper into the AWS IoT core. So what's contained in this service? First of all, we have a MQTT message broker. Then we have a certificate authority built into that service. So why do we have a certificate or authority built into the service? So when you connect your devices to AWS IoT, we require that you have TLS 1.2 and you use X509 device certificates to authenticate your devices against the AWS IoT core. You can use the certificate authority that is built into the IoT service, but you can also bring your own certificate authority. You can also use Cognito identities for authentication. Cognito is a service that allows you to bring either your own identity provider or use one of the large identity providers like Amazon, Google, or Facebook to authenticate your devices. So Cognito is more meant for applications that you create to access IoT services where you have to enter, for example, a user ID and a password. If you connect really devices, sensors and so on, then you should use X509 device certificates for the authentication, because then you don't need to store any credentials on your device. So now when we have methods to authenticate your devices against the service, we also need methods to authorize your things, to do something within the service. And therefore, we have IoT policies. If you have worked already with AWS and you know IAM policies, IoT policies look similar from the structure. They are also JSON documents, and they look similar to IAM policies, but they allow certain actions for your devices or authorize your devices to fulfill certain actions within the AWS IoT service. So MQTT is a publish subscriber protocol. So that means your devices can publish messages or subscribe to certain so-called topics to receive messages. And with these IoT policies, you can define, for example, which device may publish to a certain topic or which device may subscribe to certain topics. So then you have also the authorization and the authentication through X509 certificates. And how do you glue this together? So you will attach a IoT policy to a device certificate, and that allows your certificate or the device which holds the certificate to do and to act within the IoT service in the MQTT message broker. Then we have a service which is called Device Shadow, and the Device Shadow is meant to represent the state of a device and also to send commands to a device even if the device is offline. So how does it work? If you have a device, for example a light bulb, when the light bulb comes online, it would report its state to the device shadow. That means, for example, I am off. Then you have an application that wants to switch on the light bulb, and this application would send a message to the device shadow and ask the light bulb to turn on. So then the device shadow will create a delta. That means you have a so-called reported state which is off and a desired state which is now on, and now the light bulb must resolve this delta and report back to the device shadow that it was now switched on. So even if the light bulb would not be online, the device shadow would store the information so that when the light bulb comes on again, it can read the messages from the device shadow and act accordingly. And the AWS IoT Core service is a managed service. That means there's no installation for you. The service scales automatically. You don't need to pre-provision anything. It's built redundantly across multiple availability zones. And we have here a pay-as-you-go model. So that means if you connect devices, if you send messages, if you use the rules engine, you will pay for that. If you don't pay for that. So I mentioned also earlier the rules engine. And the rules engine is a really cool component of the IoT core service because it allows you to filter your messages with a SQL-like syntax and write rules. That means you have to send your message as JSON formats. Then you can apply SQL-like syntax. That means extract or select some keys of your payload and then send this payload or parts of the payload to other services. You can also use, for example, a select star. That means select the whole payload. You can also augment or filter data with the SQL syntax that we do provide. And then you can create so-called actions. And with the actions, you define where you want to send your data to. For example, you can save your data to other services like Amazon S3, Amazon Redshift, Amazon Elasticsearch service. So there are a lot of services. You can also call a Lambda function to do some calculations based on your data. And you can also republish your data to other topics. You can also send it to queues like Amazon SQS. You can send it to streaming services. They're called Amazon Kinesis. And with that feature, you can really simple send your data that you have collected to other services, analyze your data, store your data. Because if you build an IoT application, you don't only want to send data to an MQTT message broker. You want also to store your data. And when you've stored your data, you want to analyze your data. We are permanently evolving our service portfolio, and over time you will have probably more and more services that you can use to analyze your data. So let's look at the rules engine, how a SQL syntax could look like if you create a query. So compared to SQL and databases, you would not select data from a table, but from a topic here, from an MQTT topic. Here we have a statement where you select all the data from a message which is published on the topic/structure, and where the temperature is greater than 35. You can use conditions, but you need not to use conditions. You can, for example, use conditions in this example here to create really simple alarms. So that means if you select your data from a temperature sensor, from this example here, and the temperature is above 35 degrees Celsius, you can send this message, for example, with the rules engine to an SNS topic. And the SNS topic can send you an email, for example. And with that, you have really created a very, very simple service for monitoring and alarming your devices. Okay, then let's look at AWS IoT device management. The device management service is a service to onboard, organize, monitor, and also manage remotely your devices. So first of all, we have the first part is onboarding. So we have a batch fleet provisioning services here. That means you can provision in advance large amounts of devices in the service. We have real-time fleet indexing and search. That means you can really easily search the device registry in AWS IoT compared to the former capabilities where you have to do a list things and then go through all the things. You can imagine if you have a large amount of things that could perhaps take some time. And now we have really a query syntax that you can use to query the device registry. We have also added the capability for fine-grained device logging and monitoring, and we can also use now over-the-air updates to update your devices. So, for example, to exchange certificates and all that stuff. I will come to each of these capabilities later on a little bit deeper. So, onboarding fleets of devices. You can upload your device information in bulk, and the service will automatically register all the devices that you have put in a file, and will also attach, for example, policies, will add the things to groups, will add attributes and all that stuff. We have also, regarding onboarding, the possibility to auto-register new devices. That means as soon as the device connects to AWS IoT, it gets registered automatically. So we have also covered authentication, which is currently X509 certificates or Amazon Cognito. But now we have also a possibility where you can write your custom authentication mechanism. And you can also manage devices that are no longer active in the service. So let's get to the device onboarding. So what can you do to onboard your devices? First of all, you can of course use API calls. That means you simply create a thing, you create keys and certificates, you create a policy or you use an existing policy, attach the policy to the certificate, attach the certificate to the thing. So you can use these steps to automate the onboarding of your devices. So now we have two other options, which is called single device provisioning and bulk device provisioning. And these provisioning options use so-called provisioning templates. In a provisioning templates, you describe the resources for your devices, and then you can either provision a single device with an API call with the provisioning template that you use, and with the provisioning template, the service will automatically create with one API call your thing in the registry. It will attach a policy based on the information in the provisioning template. It will also create a certificate, and then your device is ready to go. So if you want to do this in bulk, that means not only using a single device, but you want to provision a lot of devices, then you can use the bulk device provisioning. Bulk device provisioning will also use a provisioning template where you define what policies are attached to your devices, or in what groups your devices will be put. And you use here also a so-called parameter file, where you put all the parameters, information about your devices that you want to create into this file. For example, the serial number, you can put a certificate signing request into that parameter file. And the parameter file will have one line per device. And if you have created this parameter file, then you will upload the parameter file to Amazon S3 and call the bulk provisioning task, and the AWS IoT service will provision all the devices in the background. You do only one API call, everything is done automatically, and you will receive back as a result, if everything went fine, you will get back a JSON document with all the certificates for your devices and other information like the ARN. ARN is Amazon resource names, for example, of your things, and information like that. So, and these provisioning options that we see here, API called single provisioning, device provisioning, are options that you can use to provision your devices in advance before you use the devices. Might be you have a production plan where you create a lot of sensors, you put your certificates on the devices and create all the devices in the service before you ship your devices. Then we have two other options that they are called just-in-time provisioning and just-in-time registration. And these are on-demand provisioning options. That means you do not need to pre-provision your device, but you provision your device as soon as it connects the first time to the AWS IoT service. We have the so-called just-in-time provisioning. It makes also use of provisioning templates where you define what kind of policy your device will receive. So then you use a provisioning template, your device connects for the first time to AWS IoT, and the service will register the device in the background, will attach a policy to the device, and so on, and the device is then ready to go. For just-in-time provisioning and just-in-time registration, you have to bring your own certification authority, because you have to create certificates before your device will connect to AWS IoT, and the certificates will be automatically registered within the service. So then we have also a option which is called just-in-time registration. Sounds similar to just-in-time provisioning. It works a little bit differently than just-in-time provisioning. So what happens if a device connects to AWS IoT and just-in-time registration is enabled? So the device certificate will automatically be registered in the service, and then the service internally publishes a message to a certain topic with some information about the device, like a certificate and so on. And now you can use the rules engine, apply a rule onto that topic structure, and with the IoT topic rule you can call a Lambda function. And the Lambda function will then do all the work. You are free to do anything you want to do with the Lambda function. And the Lambda function will do all the work to provision the device within the AWS IoT service. That means also attach a policy, put the device, for example, into groups and so on. But you can also, with a Lambda function, perhaps enrich the data for your device. You can also do lookups in other databases. So outside of AWS IoT, might be you have your own database on your production plant and you want to have the information that if a device was registered, that the information is also put into another database. You can also do a lookup with a Lambda function in other services. For example, to look up what specific policy should a device get to act within the service. So that means just-in-time provisioning is a little bit more complex to set up compared to just-in-time registration is a little bit more complex to set up than just-in-time provisioning, but you are more flexible. And now we come to the next feature, which is called custom authentication. This is apart from the already existing scenarios like X509 certificates or cognito identities. And here you will also use a Lambda function to create your custom authorizer. Therefore, I mentioned in the beginning, it's important to remember Lambda because it's integrated on a lot of AWS services. And here you use a device SDK, for example, to connect your devices to the AWS IoT service. And then you define within the service a Lambda function as an authorizer. So your device will then send a token and the name of the authorizer which should be used in the request when it connects to the AWS IoT device gateway. So we support here WebSocket connections for the custom authentication. And then the Lambda function will authorize your device based on what you want to use to authenticate a device. And it will return a policy, an IoT policy, and the IoT service will evaluate that policy and we'll have a look, is a device now allowed to connect? Then it might communicate with the service, or is it denied? Then it will get a related status back so that you can then decide what are your mechanisms to use to authenticate your devices. Might be you have also in another data store information about your devices. For example, you want to use Java Web Tokens or something like that to authenticate your devices against AWS IoT. So this is one more option that you can use to authenticate and authorize your devices within the AWS IoT service. So now, which we have also introduced, are thing groups. You can put now your things into groups. For example, we have here floor, different floors and different types of devices. And you can also put your devices in multiple groups so that you can define what floor, in this example, a device is located on, what type of device a device has. So what we have also, you can have groups of groups, and you can also attach now AWS IoT policies to groups. We talked about that you attach IoT policies to certificates. This is also an option, but if you put your devices into groups and attach groups to your policies, so then some things become much more easier. For example, if you need to rotate certificates, if you have attached your IoT policies to certificates, and and you rotate your certificates, you need to create a new certificate, detach the policy from the old certificate, and attach the policy to the new certificate. Here, you put simply an IoT or multiple IoT devices, of course, in a group, and you have a group policy. And if you move device from one group to another, then another IoT policy will be attached to that device. So that makes the handling of policies a lot of more easier compared to the method to attach IoT policies to device certificates. Now let's come to the new search options into the device registry and the device shadow. You can enable indexing of the device registry and the device shadow, and then you can, for example, look up easily with that search syntax, it's a Lucene index style syntax, your devices and also attributes for devices. So, for example, you can use a version where the version of your device is an attribute that you apply to your device is smaller than 6, and attributes colors it's larger than 3, for example. You can also query the shadow with these Lucene index style. So it's really convenient to work with this kind of query and get information about your devices from the AWS IoT service. So now we have also device notifications. It's also a new feature. It applies to jobs, groups, or devices. So our service will then publish internally on internal topics information if jobs are created, if groups are created or deleted, if devices are created or deleted or updated. And then you can also apply rules onto that topic and then act, for example, call a Lambda function that does something with a device, for example, enriches data, notifies other services, whatever you want to do there. Then we have also jobs in AWS IoT, and jobs are used for over-the-air updates. And how does a job work? First of all, you need to create a job document. A job document is simply a JSON file, which describes what your update job should do. Then you need to have your own agent, which runs on your device, and which must be able to read the JSON file and to act in the JSON file based on the information. And then you will receive jobs for your devices. We have an MQTT API for that. Then your devices will report back to the service if a job was done properly. So that means if it was successful or if it has failed. With that framework, you can really do over-the-air updates, for example, for firmware updates, or get information from your devices, update software, rotate certificates on the devices, and much more. So you are really free because you write your own agent to do whatever you want to do on your device. And you can have different type of jobs. You can have jobs that are running forever. So that means if you have a group where you attach a job to, and you provision devices and put newly provisioned devices into that group, then a job will be run on that device, and yet you can use this, for example, to bootstrap your device. Now, we're moving a little bit more to the edge, to AWS Greengrass, which is a software which runs on your device, and you have local action there. You have also over-the-air updates for the Greengrass software itself. You can run Lambda functions locally on your Greengrass device. We do provide, meanwhile, a protocol adapter for OpenCUA. for Greengrass, and you have also access to local resources from Lambda functions. And we have recently added a new feature which is called a local ML inference, which allows you to copy machine learning models to a Greengrass core device and then to create your own inferences. Okay, so what are the requirements, minimum requirements? Single core 1 gigahertz CPU, 120 meg RAM, x86 and ARM as architectures, and we need a Linux as an operating system. So this is how the Greengrass setup would look like. That means you have the Greengrass core. The Greengrass core is the device that runs the Greengrass software. That device is connected to the AWS IoT cloud, and then you have your devices connected locally to the AWS Greengrass core, and you have your Lambda functions on the Greengrass core. And also the Lambda functions will run on the core, and also the devices that are connected locally can communicate with each other even if you don't have connectivity to the cloud. So it's not required that you have permanently connectivity to the cloud, but as soon as you want to update your configuration for Greengrass, of course, then you need to have sooner or later connectivity to the AWS cloud. So now, this is important to understand if you start to work with Greengrass. This is a Greengrass group concept. So the first step, if you start to provision Greengrass, is that you will create a group. This is A in this picture here. And the Greengrass group has settings, like logging settings and so on. The Greengrass group has a Greengrass core. This is a device that runs your Greengrass software, and that are the minimum requirements. That means you need to have the settings, you need to have a Greengrass core in your Greengrass group so that you can start the Greengrass software. And then you can add devices to your Greengrass group and also Lambda functions. You author the Lambda functions in AWS Lambda. That means you need to create the functions in AWS in the cloud beforehand. You also need to create your devices within the AWS IoT core before you can assign them to a Greengrass group. And then you have so-called subscriptions. Subscriptions here in the Greengrass group are routing rules that you can use to define which device or which Lambda function can communicate with which other device or which with other Lambda function. You can also create subscriptions that send data, for example, from a device through the Greengrass core to the AWS IoT cloud or vice versa. So, but it's important to remember you need to create subscriptions to make the communication happen between the components, Lambda functions, and the devices in AWS Greengrass. So now let's come to AWS Greengrass ML Inference. With ML Inference, you can put already intelligence machine learning models into the edge. And with ML Inference, you train your models in the cloud, and then you can download your devices automatically, your models, not the devices, sorry. You can download your models automatically to your Greengrass core, and the Lambda functions running on the Greengrass core can use these models to make predictions. For example, if you have a camera connected to your device and you take a picture, you can use a model that you have downloaded to the edge to recognize your images. That's, of course, only one example. You can do, of course, a lot of more stuff with this feature. So then let's come to Amazon FreeRTOS. Amazon FreeRTOS is a operating system for microcontrollers. It's based on FreeRTOS. It's still open source. That means you can use this software, you can modify the software, whatever you want to do with the software. And we have added some additional features to Amazon FreeRTOS, which makes it easy to connect your devices to AWS Greengrass or to AWS IoT. And it is based on the open source FreeRTOS, so that means this is a system which runs already on millions of devices, and there's a broad ecosystem of hardware and tools. And the modular architecture looks like the following. You have your hardware, then you have your vendor drivers, and then we have added some libraries like an MQTT agent, also a shadow library, which makes it easier to communicate with shadows. Also, Greengrass Discovery is a method to discover your Greengrass core. And we have also added over-the-air updates so that you can create your jobs. So you remember, we just talked about IoT jobs, and you can use these jobs to update your devices. So, and we have also AWS IoT Analytics, which you can use to collect, process your data from your devices really at scale. And it's also a managed services. That means you simply use the service without any pre-provisioning and can start analyzing your device data. But we will have a separate lecture about that, so I will not extend here my explanations about this service. But we have now heard a lot of about these services, about the features of AWS IoT. So now let's look at an architecture. How can an architecture really look like that you can build easily? So what I have here is an example for a sensor dashboard and notification. So, and how is it built? You have here your sensors that report temperature and humidity data. In that particular example, you can also use any other data that your sensors or your devices might deliver to AWS IoT. Then the sensors will send the data to AWS IoT. What we do then is we create a topic rule and we select only certain values from our messages. That means we have a thing ID, humidity, temperature, location, date time from a certain topic. And then we send this to Amazon Kinesis Firehose. So Kinesis are streaming services, and Kinesis Firehose is a service that automatically sends your data to Amazon Elasticsearch service. Of course, we have also the option to send data directly to the Elasticsearch service, but if we use Amazon Kinesis Firehose in between, we have two more options. First of all, Amazon Kinesis batches together your data. That means putting your data into Amazon Elasticsearch service becomes more efficiently compared to opening a connection for every message. And secondly, what we can do is we can apply here Amazon Kinesis Analytics onto our Firehose stream. That means we can really do online or near real-time analytics on our data. For example, we can also use windows in Amazon Kinesis Analytics to analyze our data. So that means we can handle multiple data sets, multiple messages at once. The rules engine here can only act on one message. With Amazon Kinesis Analytics, you can act on multiple messages. And on the one hand, we have here the dashboard. The Kibana dashboard is part of Amazon Elasticsearch service. And then we use Kinesis Analytics to find out if we have an anomaly in our data. That means if the humidity is about a certain threshold. And if this is the case, then we will send these data to another Amazon Kinesis stream. and this stream is integrated with AWS Lambda. That means as soon as you get a message here into that stream, and we remember we only get messages into that stream if we have detected with analytics an anomaly here, then we will call the Lambda function, and the Lambda function simply will send a notification with the Amazon simple notification services. And this is really a short example how you can build a small application, start quickly, and of course develop this application further and build more sophisticated applications. And I will show you now a demo. How does it look like in the real implementation? So first of all, we have our devices that are sending data to AWS IoT. And here in the AWS IoT console, I have integrated an MQTT client. So I will use the MQTT client and subscribe to the topic or the topic structure. I will use a wildcard where the devices are sending their data to. So let's subscribe to the topic, and if all is going fine, then we can see here already data that are arriving. We can see here multiple devices that are sending sensor data in different structured data. So you can see here, you have more data here from this device, and you can see here a smaller data set from another device. But they all have in common, they are sending a thing ID, humidity, temperature, daytime. So that are the keys that we do extract with our topic rule. So let's have a look at the topic rule. We have here the topic rule where we select the thing ID, humidity, temperature, location, daytime from our topic structure. I have added here multiple actions. So you can see you're not limited to one action per rule. You can have multiple actions, like store the data in S3 and in parallel send the data to our Amazon Kinesis Firehose, which send the data then to Elasticsearch. So let's have a look at how does Amazon Kinesis Firehose looks like. This is simply the definition of my Firehose delivery stream. You can really create this stream within minutes. And then we have Kinesis Analytics, which is attached to our Kinesis Firehose stream. We can see here the source for the Kinesis Analytics application is our Firehose delivery stream. And now we can go to the SQL results. So you can see here my SQL statement. And with this statement, we only send data to the other Kinesis output stream if we have a maximum humidity over 95%. But it should be only an example. So normally you would perhaps use something like an average. So if you have sensors which might fail, for example, from time to time, then the average might make more sense than using the maximum, but it's only for demo purposes. Therefore, I used this statement. And here you can already see that data are arriving on that Kinesis analytics stream. And you can see here thing IDs, humidity, temperature. You can see longitude and latitude if the data are present. And you can see the daytime that was contained in the message payload. So how does the Lambda looks like? This is really a very small Lambda function that is called if in the Kinesis stream, which captures the data sets when an anomaly is detected, it simply gets the data from the stream here in the event, in the Lambda handler as input. It decodes the payload, extracts a certain field on the payload and then simply sends a message to an SNS topic. So you see, it's not so much code. It's really simple. And now let's have a look at our Kibana dashboard. So these are the data here that are arriving into Kibana. Let's look at the architecture. Sensors sent to AWS IoT, topic rule to Amazon Kinesis Firehose, and then we send the data to Amazon Elasticsearch Service. And here we see that data also from different sensors that we have seen already in the MQTT client are arriving here in our Elasticsearch Service. And now we can use the Kibana dashboard to build visualizations. So here, for example, I have already built a visualization where you can see per device that is connected. So one is a small ESP8266 device. The other one here is a Raspberry Pi with the temperature sensor and the humidity sensor. And you can see here by device max humidity. This is for the ESP device. Or you can see here the temperature. This is for the Raspberry Pi device. And also other data here, like the temperature for the ESP device. And so you can build a really small dashboard, which is also updated nearly in real time. It's updated every 5 seconds, so that is a minimal interval that you can use with Kibana. But with this setup, with AWS IoT and its features and some of the other services, you have built then, or you can build really fast a small application and then grow your application, for example, from that setup. Okay, that was it from my side so far about the overview of AWS IoT and all the other services that you can use to build really fully fledged IoT applications. Yeah, thank you. And if you have any questions, please let us know. We will enter the question then. Thank you.